Alright folks, in this video I'm going to show you one more example about how we balance the oxidation reduction reaction in acidic conditions. Here is the flowchart we used in our lecture, and here in this video we're going to follow it. And here this is the equation that we need to balance. The first step, write the unbalanced net ionic equation. Okay, this equation has been given. So let's go to step 2. Decide which atoms are oxidized and which are reduced, and write the two unbalanced half fractions. In order to do this part, you do have to identify the oxidation states for all of the elements in this equation to identify which is oxidized, which is reduced. Let's do this. For oxygen in first species, that is -2. So if you do the math, oxidation state for chlorine is +1. For this second species, oxygen -2, hydrogen +1. Okay. Again, if you do the math, the chromium oxidation state is +3. For the two products, -2 for oxide, chromium should be +6. And chloride, since it's a simple ion, so the charge of those of the chloride is the oxidation state of chlorine, -1. All right, and then we write the two unbalanced half fractions. Once you identify the oxidation states, you can identify which one is oxidized, which one is reduced. Okay, let's do the oxidized half fraction first. Oxidation half fraction. Okay, as you can see that the chromium goes from +3 to +6, so it's oxidized. Therefore, we write the CrOH 4 minus 2CrO4 2 minus. Okay. It's a starting point of the oxidation half fraction. For chlorine, it goes from +1 to -1. Oxidation state is going down, so this is a reduction half fraction. Okay, that would be ClO minus 2 chloride. We finished the step 2. Now let's go to step 3. Balance both half fractions for all atoms except oxygen and hydrogen. When you look at this oxidation half fraction, besides oxygen and hydrogen, you have chromium. So you have to balance chromium first. You have one chromium on the reactant side, one chromium on the product side, so it's balanced. Right? Let's do the same thing for a reduction half fraction. You have to balance the chlorine first. And you have one chlorine on the reactant side, one chlorine on the product side. It's balanced, so we are good for step 3. Step 4, balance each half fractions for oxygen by adding water to the side with less oxygen, okay? And balance hydrogen by adding proton to the side with less hydrogen. Let's look at the oxidation half fraction first. You have 4 oxygens on the reactant side, and you have 4 oxygen on the product side. Oxygen is balanced. But you have to balance the hydrogen, because on the reactant side, you have 4 hydrogen, and you have 0 hydrogens on the product side. Therefore, you add 4 protons on the product side. For reduction half fraction, if you look at these two sides, you have 1 oxygen on the reactant side, 0 oxygens on the product side. So you have to add 1 water molecule on the product side to balance hydrogen, to balance oxygen. Now, a product side has 2 hydrogens, and you don't have any hydrogens on the reactant side. Therefore, based on the second part of the step 4, you have to add 2 protons on the reactant side to balance hydrogen. Okay, so we finished the step 4 already. Now let's go to step 5. Okay, first part of the step 5 is balance each half fractions for charge by adding electrons to the side with greater positive charge. Okay, let's do this for the two half fractions. On the reactant side of the oxidation half fraction, you have one negative charge here. On the product side, you have two negative charges and four positive charges, right? Because you have 4 protons, each proton is positive 1 charge, so total is 4 positive charges. Now, when you consider the overall charge of the product side, then that would be positive 2, okay? Be positive 2. Now, you have positive 2 on the product side, and you have negative 1 on the reactant side. How do we add electrons to balance the charge? Which means you have to add which means since the product side has greater positive charge, you have to add electrons on the product side to balance the charge. The problem is how many electrons do we need? Remember, each electron is one negative charge, okay? So you have to keep that in mind. And if you have 1 electrons, now let's count the charge again. You have 3 negative charges and 4 positive charges. So total right now, if you count the 1 electron, then that would be positive 1. But still, the charge is not balanced, right? So let's add 2 electrons. Now, if you count the charge, it's not positive 1 anymore. It's actually 0, which means if you have 2 electrons on the product side, the overall charge of the product side is 0. Still, it's not balanced because you won't reach the negative 1 charge on the product side to balance the negative 1 charge on the reactant side. Therefore, instead of using 2 electrons, we need 3 electrons. Okay, so let's change this to 3. And now if you count the charge, then the overall charge of the product side would be negative 1. It's balanced because both sides now have negative 1 charge. Okay, so this is how we decide which side needs electrons and how many electrons we need. Let's do the same thing for the reduction half fraction. If you count the charge, this one is one negative charge, this one 2 positive charges. Now, if you do the math, overall charge on the reactant side is positive 1, right? And then on the product side, you have 1 negative charge and you have neutral molecule. Overall charge is negative 1. So since the reactant side has a greater positive charge, you do have to add electrons on the reactant side. The problem again is how many. If you have 1 electron, then you count the charge. Okay. If you count the charge, now it should be 0. Okay, it should be 0 now. Let's erase this to give you a better idea about what we are doing. So here the overall charge is 0, but still the charge is not balanced because on the product side it's negative 1. So you need 1 more electrons. So you need 2 electrons total, and now you count the charge. Now it's on the reactant side, the overall charge is negative 1. Now charge is balanced. Okay, so this is how we do it. The second part of the step 5 is the multiply by a suitable factor to make the electron count the same in both half fractions. Now, when you look at this, oxidation half fraction, it will generate 3 electrons, right? And the reduction half fraction, it needs 2 electrons to proceed to the product side. As you can see, the electrons generated by oxidation half fraction mismatch with the electron consumed by the reduction half fraction. In order to balance the 2 half fractions, you have to make sure the electrons get transferred in both half fractions are the same. Okay, so 3 electrons, 2 electrons, how do we make them the same. So here's what we are going to do. We multiply a factor to force this oxidation half reaction to donate 6 electrons, which means we multiply a factor by 2. You multiply all the coefficients of the species by 2. So 4 times 2, you get 8 protons, and now you get 6 electrons. All right? How about the reduction half reaction? In order to make this reduction half reaction consume all of the 6 electrons donated by the oxidation half reaction, you multiply all of the coefficient in this reaction by 3. Okay, so you multiply 1 by 3, multiply 2 by 3, that gives you 6, and then you get 6 here, and then you get 3 and 3. Now, as you can see, this one donates 6 electrons, and this one consumes 6 electrons. Electrons are balanced between the two half fractions. Okay, and then we finish the step 5. Step 6, add the two balanced half fractions together and cancel electrons and other species that appeared on both sides of the equation. So what you need to do is you add these two half fractions together, products 2CrOH4 minus plus the 3Cl minus plus 6 protons plus 2 electrons. Okay, so this is the reactant side. Product side, you have 2CrO4 2 minus plus 8 protons plus the 6 electrons plus the 3 chlorides and let me see if I can write it here. 3 water molecules. Now we cancel the this is a this should be 6 electrons. My bad, 6 electrons. Now 6 electrons get canceled, and the protons, you have 6 protons on the reactant side, and you cancel this 6 protons on the product side, and you only have 2 protons left. Okay, and then if you check the reaction, there is no identical species on the two sides anymore. So the final version of this equation would be 2CrOH4 minus plus 3ClO minus plus, that's it on the reactant side. And then for the product side, that would be 2CrO4 2 minus plus 2 protons. Okay, you have 2 protons left after you cancel the 6 protons, plus 3 chloride and 3 water molecules. Now let's just do the final check. You have 2 chromium here, 2 chromium here. Chromium is balanced. 8 oxygen in this species plus the 3 oxygen here, you have total 11. 8 oxygens plus 3 oxygens, 11 oxygens. Oxygen is balanced. Proton, you have 8 protons total in this species, and you have 2 protons plus 6 protons, 8 protons. Hydrogen are good. Now 3 chlorine, chlorines are good. Now, so this is a final version of this. This is overall net ionic equation for this reaction. Okay, so I hope this example can show you, detail about how we follow the flowchart here. Please do more practice and let me know if you have any questions. Thanks.